DocTalk is brought to you by Merck Animal Health. At Merck Animal Health, we're shaping the future of animal health with pioneering science, connected technology, and insights-driven solutions to bring our customers an unparalleled portfolio of choices to improve cattle care and operational efficiency. We support you and your legacy by helping you meet the challenges of today with the innovations of tomorrow.
Hey folks, welcome to DocTalk. I'm Dr. Dan Thompson. Thanks for joining us today. Dr. Aspen Workman, Dr. Vander Ley are going to join us here in Lincoln, Nebraska. We're going to talk about BVD, we're going to talk about gene editing, we're going to talk about BVD resistant cattle. Thanks for joining us. We'll be right back.
Bovolus Nasalgen 3 offers young calves unrivaled protection against devastating respiratory diseases, including IBR, PI3, and BRSV. And it has a unique blue shadow, so there's no second guessing which animals have been vaccinated. To up your protection, choose Bovolus Nasalgen 3 PMH, the first and only intranasal that protects against viral and bacterial pneumonia. Talk to your veterinarian and visit nasalgen.com to learn more.
When the ones who have your heart need your help, count on us for everything they deserve, delivered fast. We'll work hard for you so you can work hard for your dreams.
Hey folks, welcome to DocTalk. I'm Dr. Dan Thompson, and I am here with Dr. Aspen Workman and Dr. Vander Ley. And you can see behind us, we are here in Nebraska, at the University of Nebraska, where this is Husker country, right? Dr. Vander Ley is an associate professor at the Great Plains Veterinary Education Center here in Nebraska. Dr. Workman is a research microbiologist at the USDA Meat Animal Research Center in Clay Center. And, you know, it's just been an unbelievable working together between the University of Nebraska and USDA in Clay Center between GP Bec and Mark, right? Those who everybody knows, Mark and GP Bec. And this is really fun for me because the work that you've done and what you're doing is going to change our industry. I know it, and very thankful. And so we're going to get into this and talk about some of the things they've done with genetics to produce a BVD resistant bovine, and it's incredible. But Brian, kind of walk us through why BVD is bad.
Yeah, BVD has been a problem for a long time. BVD is one of the most important viruses that we fight with in cattle because it's kind of got a bad name because it's bovine viral diarrhea virus, but it actually is a highly immunosuppressive virus. So when we think about respiratory disease in feedlot cattle or pneumonia in young calves, that's a big driver, that immunosuppression that BVD causes. So we've been working on it for a long time. The first reports have come out over a century ago, and there's been a long history of people in veterinary medicine trying to find solutions for BVD that whole time. So we see a lot of vaccine use and a lot of testing, a lot of expense, and then the estimates of economic loss associated with BVD infections in feedlot cattle are significant.
Yeah.
Even worse when cattle are as valuable as they are right now. So
yeah. And kind of the Trojan horse, right, is that persistently infected calf. And how does that interplay with this?
Yeah, so the persistently infected calf is a unique thing. We don't see that happen very often. In fact, I'm not sure it happens anywhere else in nature, does it? So these calves get infected when they're in utero, they're in the cow, shortly after the cow gets pregnant. And that calf's immune system is trying to figure out what's self, what's me, and what's outside. And at that point, the immune system is getting rid of all the stuff and all the parts of the immune system that are going to react against that calf itself. If BVD shows up right then, BVD gets recognized as part of the calf, and the calf can never get rid of it for the rest of its life. And they turn into the typhoid Marys. They shed lots of virus out of essentially every secretion, everything that comes off of or out of that calf is full of virus.
Yep. And you said that our current tools today to kind of take care of it has been vaccination and testing, right?
Mm-hmm. Yeah, so the testing and vaccination are successful. They work. They have challenges associated with them. One of my favorite USDA NOMS studies shows that about 4% of U.S. cattle producers cow-calf producers test for BVD infections, but 67% of them actually vaccinate for them, which tells me that most producers view it as a problem their neighbors have. So,
Right. Yeah, exactly. And, that means a third of them aren't getting vaccinated.
Right.
And then those are the ones that come to my feed yards. Anyway, let's take a break. When we come back, more with Dr. Workman and Dr. Vander Ley. We're here at Nebraska. We'll be right back after these messages.
Well, hi, my name is Dr. Kirk Ramsey. I'm a professional services veterinarian with Neogen. So today on Cattle Intel, we're going to talk about the calving kit essentials, the things that we need for our calving kits. So my first recommendation is always to have clean, dry towels. These can be used all throughout the calving process, but they're really critical to helping dry off newborn calves and stimulate breathing. The next are OB chains and handles. Make sure to always have them clean and dry after each use. A stainless steel bucket is a must for every calving. They can be used to transport clean water, wash in, pump out of, and are the easiest to keep clean and sanitary. Some other items we should always have on hand are palpation sleeves, gloves, and waterproof clothing. Other essential items include mild soap, obstetric lube, a calving head snare, and a calf jack. But also don't forget about the things you might need when a calf is born. Items such as an esophageal tube feeder, clean bottles and nipples, a calf blanket, or heat lamp. Also, some colostrum replacer is really important if you needed it. The calving process usually proceeds without concern. However, if it does not go as smooth as expected, it is important to visit with your veterinarian and determine if there are items such as antibiotics or anti-inflammatories that might be essential for your herd. This is obviously not an exhaustive list, but it will definitely help you get started on the right foot.
Thanks for watching Cattle Intel by Neogen.
We have fed for the same customers for the last 10 years. I know their cattle. Sometimes cattle can come in a little wild, long haul cattle. Those types of cattle get therapies to help those settle in better. And we have also adapted that a lot of our sick cattle, by the time a cowboy pulls them from their pen, drives them to a hospital, and then either getting returned to the hospital or returning to the home pen, I believe that's a lot of stress on the animal. So anything that's been treated gets therapies, and we have seen success with that as well.
Plant the seeds of financial security today with United Patriot Coins Precious Metal Starter Pack, the Patriot Pack. Exclusive offer for our DocTalk family. Call now and secure your financial future. Strengthen your roots with silver and gold. Call United Patriot Coin today and ask for the DocTalk special offer.
When the ones who have your heart need your help, count on us for everything they deserve, delivered fast. We'll work hard for you so you can work hard for your dreams.
Hey folks, welcome back to DocTalk. Dr. Dan Thompson here at the University of Nebraska at Lincoln with Dr. Brian Vander Ley, who's an associate professor at the Great Plains Veterinary Education Center, and Dr. Aspen Workman, who is a research microbiologist at the USDA Meat Animal Research Center. And kind of talk me through what the terminology and the processing, this gene editing, genome editing, what does that entail?
Right, so this new technology that's become recently available is called gene editing or genome editing, or you can sometimes hear it called CRISPR editing.
Sure.
And really, this technology is really exciting because it allows us to make very specific targeted changes in an animal's genome to try to get a new and desirable phenotype. So BVD, kind of like all viruses, needs to get inside of a cell in order to replicate itself and cause disease. And the way that the virus gets into the cell is that it recognizes the specific protein on the cell surface known as a receptor. And this receptor kind of serves as a doorway that lets the virus come inside of the cell so it has access to all the resources of the cell in order to replicate itself. And so it's like the virus has a key. So it interacts with this protein, it can unlock the door and get inside of the cell. In our case, we were using this new gene editing technology to make a very small, precise change in CD46 in the gene that encodes that protein, so that the protein is still expressed on the cell surface, so that door is still there, that door is still functional, but it's like we've rekeyed the lock. So now when the virus tries to interact with that protein, it's like it doesn't have the key, and so the virus can no longer use that doorway to get inside of the cell and cause disease. So we're trying to use this technology to make a very, very small, precise change in a single gene to effectively block BVD infection in cattle.
It's unbelievable. Okay, so when you say we're doing something with the genotype to have a phenotype, you're saying you're doing something with the genetics inside with the cells to have a desired outcome or appearance or immune response, right?
That's absolutely correct. Yep.
And so I guess one of my questions is, because this sounds, I mean, it's, how long did it take to do something like that?
So in our case, we already knew which was the receptor that was required for BVD infection, and work had already been done they knew the exact residue, so the specific place on CD46 where the virus interacts. So that took years of research before we even came into the picture. And then we collaborated with a company that specializes in gene editing. So we collaborate with the company Excelligen. And then the actual process of making the edit, once you know the target and everything, doesn't take that long. We can make an edit in a cell in about a month, but then you have to take that through producing a live animal, and so that can take.
So one of the questions then, obviously, is this gene deleted in the wild already? Are there some animals that have that, or is this just something that none of them have it?
So what's special about this is that we can use gene editing. In conventional breeding, what you want has to already exist in the population, right? And with gene editing, it doesn't have to already exist. You can introduce something that doesn't exist in nature, and that's what we did here. This is a change in that one particular gene that doesn't normally exist.
So then, nature. If this animal or animals that you do that to propagate, then they could pass that genetics on to the next generation, or potentially.
Yep, that's right. So they have this change in every cell in their body, and so it is heritable. It will pass on to the next generation.
It absolutely blows my mind. And folks, if you haven't ever looked at what they do at the USDA Meat Animal Research Center and Great Plains Veterinary Education Center, I mean, this is the hub of animal health research in the United States and the world. And it is an absolute gem for all of us to be proud of. And for y'all to do this for us, for our industry, for veterinarians, just remarkable work. So when we come back, we're going to get into talking about specifics of the animal that they produced that is resistant to bovine viral diarrhea. You're watching DocTalk, and we'll be right back.
In the livestock industry, castration is a common practice to ensure proper herd management. All methods are painful, regardless of the age of the animal. At Solvit, we could not ignore the clear industry need for better castration solutions. So we developed Lidoband, a novel lidocaine-impregnated elastrator, addressing the pain associated with band castration. It provides local anesthesia throughout the castration process. Lidoband, a small device that can make a big difference.
Ranchers, looking to elevate your pasture management game? Turn to Heinen Brothers for expert aerial application. With state-of-the-art equipment and seasoned pilots, we deliver precision treatments right to your fields. From fertilizers to herbicides, Heinen Brothers has your pasture covered. Visit HeinenBrosAg.com to learn more.
They're here, they're hungry, and they can't be stopped with ivermectin. Choose Safeguard when you deworm your cattle to take out resistant parasites like brown stomach worm, Cooperia, Nematodirus, and others. With Safeguard's efficacy, you can kill more resistant worms in your cattle, so you don't leave potential on the table. Consult your veterinarian for the diagnosis and treatment of parasitism, then bite back at safeguardworks.com.
Hey folks, Welcome back to Doc Talk. I'm Dr. Dan Thompson with Dr. Brian Vander Ley and Dr. Aspen Workman. Dr. Vander Ley is Associate Professor at the Great Plains Veterinary Education Center. Dr. Workman is a research microbiologist at the USDA Meat Animal Research Center, and we are in Lincoln, Nebraska. As you can see behind us, we are at the University of Nebraska. Just a beautiful facility, beautiful campus, unbelievable curriculum. So if you get a chance, swing through Lincoln. A lot to be proud of here with what y'all do for animal health, production, animal performance, meat, everything that has to do with cattle. UNL has been central to a lot of it. So we want to get into talking about the production of this animal that is resistant to BVD, this heifer. So talk about, where did it start? You talked about the CRISPR and the gene deletion, but then after after you had that figured out, what were the steps that you did to show that this was going to work?
Yeah, so we really took a stepwise approach in trying to see if this edit would really protect first cells in the laboratory and then a live animal from BVD infection. So we started by just taking cells that are typically grown in the laboratory for studying BVD, and we first made the edit in those cell lines. And so then we can characterize what is the impact of this edit on susceptibility to the virus in the laboratory.
Yep.
Because then we can test a wide number of virus isolates from BVD. There are two main genotypes of BVD. So in the lab, we can test these cells against both genotypes of the virus, against all the different subtypes of BVD that circulate in the US, and begin to kind of characterize what's the impact of this edit. And then once we felt really comfortable in the cells in the laboratory that this edit is giving a phenotype that we expect and that we would like to transfer to an animal, then we took this technology to try to apply it to creating an animal that actually has this desirable edit in it.
And what were the next steps, Brian?
There's a couple of really important things when we do any kind of genome editing like this. We want to make sure that we don't create unintended consequences. So there was a tremendous amount of effort put in by some of the other members of the team to make sure that the edit happened exactly where it was supposed to happen and that there was only one. We didn't want to put a bunch of copies of the edit into the genome of this animal, because we would get other kinds of effects if we did that. So that edit was confirmed through whole genome sequencing. So they looked at Ginger, the animal out here, from one end of her genome to the other, made sure that the edit was in the right place. It was on both sides of that DNA strand, so both copies were good, and then that there was only one. So after that, then the next part of the process to see if we can get a live, healthy calf. And that part it's pretty interesting. There's a lot of reproductive technology that goes into gene editing. There's the whole gamut of things that we would do in normal bovine production today anyway. There's technology like IVF and cloning are pretty common, even in commercial animals. So a lot of that stuff has to happen. And we ended up with an animal that is healthy by all the measures that we can get. And she's doing really well, even today, as almost a 2-year-old.
To take the stepwise approach in vitro and then produce a calf, that's a lot of work, folks. And so thank you for explaining that. When we come back, we'll talk about some of the tests that you put Ginger through, right, to make sure that it worked. And we'll talk about the future of this technology. Incredible stuff. Dr. Vander Ley, Dr. Workman, we're at University of Nebraska, Lincoln. We'll be right back. Hey folks, for your firearm and ammo needs, for gun safes and much, much more, and to have it personalized, come visit us at United Patriot Supply outside of Seneca, Kansas. You can also visit us online at unitedpatriotsupply.com. Be sure to say that Dr. Dan and DocTalk sent you, and we'll see you down the road.
Hey, I'm Clark Victory. I grew up right here on this little ranch near Chelsea, Oklahoma. Roped and ranched all my life. A few years ago, I had an injury that created what they call a frozen shoulder. And after speaking with the surgeon in Tulsa, he told me that he could make my shoulder better if he did surgery, but he absolutely couldn't fix it. And I called Kansas Regenerative Medical Center. I did the stem cell replacement. By 12:30, my wife and I had lunch and was driving back to Chelsea. We work around here. Some days we work pretty hard around here, and My right shoulder doesn't get sore. It's like a baby's arm.
Time is money on the farm, and your cows are less productive when they're stressed. The Alertus on-farm test from IDEXX allows you to quickly test cowside and identify open or pregnant cows within minutes on your schedule in the parlor, barn, or chute. It's more efficient for your farm, very simple to use, and puts you in control. With minimal training and reliable, fast results, sample-based pregnancy testing is better for beef and dairy producers. Learn more at idexx.com/DocTalk.
Success in the cattle business hinges on a lot of different people playing their part, from the vet to the cowboy and the nutritionist to the feed truck driver. You rely on them to get their job done right, and so do your cattle. Your expectations for the vaccines you use should be no different. Bimeda's cattle vaccines were developed and are made and sold by men and women in the cattle business. No smoke and mirrors, just real-world protection that you can rely on. Go to BimedaBiologicals.com to learn more.
Hey folks, welcome back to DocTalk. Dr. Dan Thompson here with Dr. Brian Vander Ley, Dr. Aspen Workman. Dr. Workman is a USDA meat animal research microbiologist, and Dr. Vander Ley is associate professor here at GPVEC, Great Plains Veterinary Education Center, associated with the University of Nebraska at Lincoln. If you've been to the Academy of Veterinary Consultants or been at NCBA, you've seen Dr. Vander Ley speak all across this country on bovine health, and the research that they're doing together. Just really, really incredible. And we're very thankful you took the time to spend with us today. Let's talk about what we did with Ginger then, after she was born, and how you tested to make sure that she was resistant to BVD.
Yeah, so I can address that a little bit. So just to clarify, I don't think we've talked about this yet, but Ginger is the gene-edited heifer that has the edit that changed the lock on the door for BVD. So BVD should have a hard time getting in, but we wanted to make sure that, Dr. Workman did a lot of work in the lab to show that BVD really does have a hard time getting into these cells. It worked really well in the lab, but the proof has to be in the live animal if we want it to work in the field. So we needed to do a live animal challenge. There's a lot of different kinds of challenges that have been done out there. You can do really simple ones where you just expose them at one point, just put some virus in their nose or something like that. But we wanted this one to be real life. So we got a persistently infected calf. And we actually, they were in a room, like a pen that was relatively small, and we put the calf in with Ginger and the control animal. And we actually have some really good footage of the challenge taking place because there's a lot of nose-to-nose contact. So we were confident that they were exposed.
So when an animal is first exposed to BVD, the virus replicates in the upper respiratory tract and then makes its way into the blood. And the blood carries BVD throughout the body. And in the blood, BVD infects and kills the white blood cells. And so we looked for the presence of BVD in the blood of Ginger and then our just normal wild type control calf to see, is the virus making it into circulation? And what we found is that in Marianne, which is the name of our just normal wild type control calf.
I get it now. Marianne and Ginger. I'm slow, but
we could detect BVD in her white blood cells for about 2 weeks after the exposure. We could detect virus in her blood. Whereas for Ginger, we could never detect infectious virus in her blood, and her white blood cells remained uninfected during the entire course of our challenge study. So that has huge implications for controlling BVD and the spread of BVD. Yeah.
It's unbelievable. It's so refreshing and so cool. So what's next?
I think the big next step, the big next question is that most important infection happens in that calf before it's born.
Yep.
And we have some plans to do some research to look at challenging heifers or cattle that are pregnant, carrying calves that are edited to find out if that edited fetus can protect itself from the virus infection. We also, we have one animal. That's one of the consequences of doing the type of work we had to do. So it's really important. We want to make sure that before people spend a lot of time and money adopting technology like this, that we have thoroughly assessed it. So we actually have a group of calves that are gestating right now, I think they're Angus calves. They're going to look a little different than the one we've got today. And that we're going to redo the challenge. We're going to make sure that it works a couple of times, and we're going to do it with a few more animals. But I think the key thing is to make sure that that edit will protect the calf in utero, to make sure that we break the chain of making new PIs, which is really where the leverage to stop BVD is.
Absolutely.
So,
well, thank you both for taking time out of your schedule. Thank you for being on the show. But most importantly, thanks for working together and bringing something to the industry that is just off the chart exciting.
Thank
Thank
you.
you.
Yeah.
Thanks for having us.
So thank you for watching DocTalk. This has been maybe one of the most interesting shows I've ever got to do, and just a lot of fun here at the University of Nebraska. Thanks to USDA Meat Animal Research Center. Thank you to Great Plains Veterinary Education Center. Thanks for watching. If you want to find us on the web, you can find us at www.doctalktv.com. Always work with your local veterinarian. And I'm Dr. Dan Thompson with Dr. Brian Vander Ley and Dr. Aspen Workman, and we'll see you down the road.
At Merck Animal Health, we're shaping the future of animal health with pioneering science, connected technology, and insights-driven solutions to bring our customers an unparalleled portfolio of choices to improve cattle care and operational efficiency. We support you and your legacy by helping you meet the challenges of today with the innovations of tomorrow.